Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
How do you tell Will wrote the episode? It starts out, if you've ever. No, I'm just messing with you, dude. You put that in a lot of episodes.
I think it's a good way to start these kind of things, though.
Yeah.
So,
guys, if you've worked on complex or distributed systems at all, at some point, you've seen them produce behavior that is predictable in hindsight, but that you never would have predicted yourself. Systems tend to take on a life of their own, especially as different parts are developed at different rates by different people. In this episode, we're going to discuss how you can be better at predicting and understanding the behavior of systems that are more complex than simple programs. But, Will, what's been your complexity this week?
power outages. We've had a lot of them.
Oh, fun.
So Saturday night, our power was out for a little over 3 hours. It started right in the middle of dinner. Yeah, that was severely unhelpful. It ran every battery backup in the house down to nothing because I just, shut things down when stuff, goes critical, basically. Yeah, so that was pretty irritating. And then we had more of them last night. In fact, it got so bad last night with the power turning off and being off for a little bit and then turning back on that I basically shut everything down, but the alarm system still kept me awake, among other things. And I ended up just taking a sick day today because I was so exhausted. So I guess like a bunch of tree branches must have, fallen, overnight during the very, very small storm that we had.
We did have a storm, that's true.
Yeah, but it wasn't much of one. Now, Saturday I understood because there was lightning everywhere, but last night was not that substantial, I don't think, at least not here. So yeah, that's pretty irritating. During the day today, I actually went to every UPS in the house and I have turned off the beep, except for one really, really old one that has some kind of weird plug that isn't a USB that I don't know what it is supposed to be. And, the actual alarm system for the house. And I'm working on getting those two sorted out. So I'm not going to be getting beeped at when the power goes off. I'm well aware the power's off. How about you?
So, did a little work on my bike this past week. May not actually be the alternator that is the issue. So I thought, hey, I'll plug it into the trickle charger and just charge up the battery, while I'm waiting on ordering an alternator and stuff. And so I hooked it up. Well, actually, I already had the wires hooked up, and I plugged it in basically, and it kept telling me that it wasn't hooked up properly. So I fiddled around with it. I tightened the screws, loosened the screws, and I found if I pressed down a lot, it would turn on. I was like, oh well, maybe there's something wrong with the ground, and so I tried hooking the directly to the frame, and yeah, that didn't work. And so what I figured when I took it apart was the little part that goes hooked onto the battery, onto the positive and negative parts. Sorry, I don't know the technical terms. I just know what goes where. Anyway, I realized that doesn't quite fit. It's just it's got this flat plate and then these little kind of things coming around it sort of to wrap around, and it just barely doesn't fit. And I was like, oh man, I thought this battery was the right size. I took my old battery in and they compared it and it was the exact same size. So I'm not really sure if maybe there's some expansion or something like that. But I think I can bend those just a little bit to get that flat plate down against the would be the electrodes. I'm not really sure, but the part of the battery that it's supposed to be touching that's not. So I'm gonna be working on that, getting that all together and stuff. So I don't know. I'll probably tinker with it some this week.
Are you talking about like the cathode and the anode?
Yeah.
Okay.
The red,
I
and
was
the black.
like the things. Like what?
I don't know that. I couldn't think of the names of the red and the black, the positive and the negative.
I was all right. Yeah.
Yeah. So like, but the part of the bike that hooks onto that, it doesn't quite fit around the battery piece. And I don't know why. I thought it did when I put it on there. I don't know if like what happened, but I think I can just sort of bend it a little bit and get that to fit. That's what I'm going to try first because it's the right size battery. I don't know why it's no longer fitting. So, but yeah, that's what's going on. It's a 10-year-old bike, so yeah, it's got some quirks. So, with that said,
saving money is hard, especially when you have a 10-year-old bike.
True that, yo. Lucas Casadas is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
And just like us here at Complete Developer Podcast, his focus is on helping you to not only establish a real plan, but also to take action so that you can live your best life by living out that plan.
Guys, investing in financial planning services, it really boils down to whether or not you can make an impact and improve your finances. With the help of Level Up, that compounding effort of making better financial decisions will easily pay for itself.
Level Up also has a unique pricing model that will help you no matter where you are in your financial journey, so you don't have to worry quite as much as you might with other places.
And best of all, Lucas is a fiduciary for his clients. What that means is he's not here to sell you a product, but instead to help guide you to a better financial situation.
And speaking of guidance, you can catch his podcast, Techie Personal Finance Bootcamp, where he covers financial topics that you probably face. And he also interviews other IT professionals who share how they navigated their own careers. And he has even more guidance and useful material available at levelupfinancialplanning.com.
We've all written nice, clean, and concise programs that worked well. We've shipped them to production and had them run in a stable fashion for months or even years, only suddenly to start experiencing problems when something in the environment changes. If you're like most of us, you conclude that this isn't the fault of your code, but rather the fault of recent changes to the system. And you'd kind of be right. But the fact is that your code is the part that ended up breaking. If you've ever had this experience, then you're well aware that the way you look at code in development is very, very different from how you look at it in production. In production, you are part of a much larger ecosystem, a part of which you don't control. Most of which I would say you don't control.
Yeah. Well, especially once you get to the OS level and your cloud provider and just the internet in general. Yeah, you have a minuscule amount of control. And there's another problem as well. Developers in particular and human beings in general make use of abstractions when they're trying to understand the world. And those abstractions are necessary when trying to dig into something because they limit the scope of things that you have to worry about. However, abstractions also have a really nasty habit of leading to blind spots. And when you have any blind spots in your thought process, surprises tend to ensue. Human beings also, as a whole, have a tendency to understand things in a linear fashion. Exponential situations or situations with things like feedback loops are not part of most people's everyday thought process, even though they're completely all around us all the time, both in nature and in technology. This focus on linearity is also a blind spot, and it's really just another bad abstraction.
Compounding the problem for developers to effectively write and debug most code, you really need to think of it in a linear fashion with the appropriate abstractions. However, at some point, the very thought processes that make you capable of writing the code are going to hinder it from running well in production. You need to be able to shift in and out of both mindsets if your code is going to run at scale and be stable.
In this episode, we're going to talk at a high level about some of the thought processes that are useful when building systems that live in a complex, dynamic environment that you don't totally control. Understand this as well. That's literally every production environment out there. So these thought processes will probably be helpful to you, even if you don't believe your system is all that complex. In the Aftercast, we'll discuss some ways that team leads and senior developers can help junior and mid level developers become better at systems level thinking.
So, first off, you need to think in terms of feedback loops instead of linear processes. We just said that, basically. Right.
Yeah, well, this is how you keep your system from running off the rails. And we're going to kind of talk about the engineering thought process here. A leads to B, B leads to A. That's a feedback loop.
Mm-hmm.
Right?
Yes, it is. That's a very basic one.
Yeah. There's two types, positive and negative. A negative feedback loop will dampen output as input increases, whereas a positive feedback loop will amplify output with more input. So in things like social movements, positive feedback loops are often nice to have. It's virality in a social network type environment, for instance. While in an engineering situation, a positive feedback loop is generally considered to be a negative event.
Yes. So, for example, when dealing with a motorcycle battery, a negative feedback loop means you're losing charge. A positive feedback loop means an explosion. Woo, right. Fun.
Yeah. Well, I was thinking you were going to go a completely different way because, with all the sound engineering stuff that you do, putting a microphone in front of a speaker, that is a positive feedback loop. It keeps getting worse.
Yeah. It adds to it. Positive, not in a good sense, but positive as in it adds to it. Yes, that is a positive feedback loop. I didn't think about that. I really haven't done a lot of sound engineering lately, mostly, musical, like playing the instruments instead of mixing them. Except for Alicia's wedding, I did mix a little bit there, but
let's do an example everybody knows, because we all lived this, at least in the States and lots of other places, or either you lived it or you pointed and laughed at the people that lived it. And that is, if you look at the toilet paper shortage that we had at the beginning of COVID, that was an example of a positive feedback loop, right? Because some dude goes, "Oh my goodness, we're going to run out of toilet paper," because he thinks they ship it from China. It's not worth shipping from China, by the way. It's huge and it's not worth a lot of money. Like you don't really, it's not space efficient to ship that. But some people thought that it was, and so they ran out and they bought all that the store had. Well, then the next person sees that, hey, the supplies are running down, so they go somewhere else and they buy all that's available. Now you got a positive feedback loop. And eventually even the people that know better have to participate in this loop, because if they don't, they're going to be out.
Unless they were my mother and bought in bulk before it was cool.
Yeah.
My hipster mother.
I bought in bulk beforehand because I figured that something would run out. I wasn't sure what, but I made sure that we were good on supplies. But when I read about the land border between Russia and China getting closed, I was like, okay, that's a big trading partner. Probably ought to go look at that.
Yeah, absolutely. So think of positive feedback loops as existing within negative ones and vice versa. This sounds really confusing because Will wrote it. No, just kidding. For instance, had the toilet paper run continued, driving prices up, it would eventually become more lucrative to manufacture toilet paper, eventually killing the run when a surplus was created. That which can't continue forever doesn't, is what he wrote.
Yeah. And of course, the other thing too is when you get a surplus, what happens? Well, it drops the price and it makes it less valuable. So you have a shortage following the surplus a lot of times. Like you'll see that in economic models. But it's important to understand the concept of the feedback loops, and then understand that every feedback loop lives inside of another one. Typically, at least the ones you're going to deal with, right? Like at some point it goes to something you can't control at all, and that's that.
Hopefully we'll hit the negative side of the gas feedback loop soon.
Yeah, maybe.
Yeah.
Yeah. Or the prices of horses will go down one. So the next point is you need to think of emergent behavior over predictable behavior. And this one is pretty hard for people to think about because it's not the normal thought process during the day. But a great example of this is a school of fish. If you want to think about an emergent behavior, an individual in a school of fish obeys just really, really simple rules. They stay close to the middle. They get away from anything that looks like a threat or is a threat. They stay a minimum distance from everything else, including each other, and they match the speed of the group. That's all a bunch of little predictable behaviors at the individual level. Now, the emergent behavior is the behavior of the school, which if you ever watched Blue Planet, that's pretty cool and not necessarily completely predictable.
I assume it's like watching a flock of birds.
Yeah, it's the same, very, very same thing. Yeah.
I don't really watch Blue Planet. I actually don't know what Blue Planet is.
It's like a documentary series on the oceans.
Oh, yeah.
Or if you've watched Shark Week, where like a thresher shark is like swimming around and, circling another group of fish, like the way the school of fish behaves.
No, I don't really watch that. Sorry, I just don't really watch much television. I don't actually have cable. So, yeah. Anyway, sorry. It just like, I'm like, I actually have no idea what you're talking about right now. So it was kind of funny with the TV shows. Yeah. So you often can't predict emergent behavior due either to system complexity or unpredictable variations in other connected systems. Because it's not just one thing that you're trying to predict. Like you could probably predict an individual like application's behavior within the system, but predicting the system's behavior itself is going to be a lot more difficult.
Yeah. I mean, well, because if we could do that, like there'd be so much money in going, oh yeah, your error rate's going to spike at 222 tomorrow morning. Right. Like if you could do that, like if either of us could do that, we could quit our jobs right now because we'd be billionaires.
So let's figure out how to do that.
Yeah, no, we really can't, instead of trying to predict emergent behavior, what you actually have to do is you try to measure that behavior and, log it essentially so that you can effectively troubleshoot when something happens and figure out why it happened.
I would say you probably can't predict individual behaviors, but you can probably start to look for some patterns.
Right. And that's kind of the idea, right?
And precursors. Yeah.
You get the logging in place so that you have the data to do it, but you're like backfilling your prediction. You're not actually predicting.
Yeah, I was working with a junior developer on my team today, and we had an issue where we had like these two tables that it just kept saying table doesn't exist because we realized we hadn't been pointing to the QA database in QA. And so we were fixing that, and it was like these two new tables, they don't exist. And they were the ones that he created. So I was helping him like figure out why that was. And took me about 5 minutes. And I'm like, he's like, they're there. I don't understand. I was like, did you grant permissions?
Yeah.
And he was like, I didn't know I was supposed to do that. Again, junior developer, you don't expect him to know these things, And so I was like, yep, that's what it is. He's like, how'd you figure that out so fast? I'm like, because I spent 2 days trying to figure this exact same problem out when I was a junior developer. And I didn't have someone to come along behind me and be like, oh, I know what this is. So
yeah. Well, and the other fun thing about emergent behaviors or chaotic type behaviors is they're also very similar to they're very sensitive to initial state. So if the system had already had those tables, or for some reason your permissions were different, you might have gotten a completely different error. You might have had a completely different set of things occur in the system, and it may have pushed the pressure somewhere else. That's the thing that gets kind of weird here. Ultimately, the issue is that your code lives in the wild, but you write it in a zoo. And I'm not like, denigrating your development shop, but like literally it's a artificial environment for your code. A piece of code in your system is extremely limited in the range of inputs that it receives compared to what it's going to encounter during its lifetime in production.
Yeah. And if your code is built in a way that expects chaos to be limited, chaos will limit your code.
Yep. It'll knock it right over most of the time. And, we do have a lot of stuff built in, right, that actually tries to keep the chaos at bay and helps. But if we trust it too much, then all of a sudden when the chaos does get through, we're toast. There's the old, I forget who said this, but they said if Carpenters built houses the way developers write programs. The first woodpecker to come along would destroy civilization. And that's really kind of a truism, right? Like we make an assumption that things are going to be okay, and the instant they're not, boom. Chaotic events in production should be understood as opportunities to adjust the assumption that your code makes for increased resilience, not interpreted as failures that can or even should necessarily be avoided at all costs, even though you probably should spend some time to try to mitigate them if they're bad enough, right? Like sometimes databases are not available. Sometimes your payment processing system's offline. Sometimes, something weird's going on and you got to deal with it. And it's not like, oh, well, I'm going to keep my database has got to have perfect uptime or, the world ends, because guess what? If those are your options, then the world's ending.
A really great example of this, and I was thinking of it before reading this point on the outline, is Netflix's Chaos Monkey. Almost started making monkey sounds when we were talking about chaos earlier, but I held that in. I did not. It randomly turns things off so that systems must be built with a dynamic, chaotic environment in mind, because that's going to happen.
Yeah. Well, and the thing is like you push the code out there and it doesn't handle that, and you get nailed immediately instead of it being a core part of the system that suddenly falls over 2 years from now.
Yeah.
Which is the kind of point there.
So next, understand when to use synthesis and analysis. So if you have half a cow, you don't have a smaller cow. You just have a freezer full of beef. Sorry for our vegan friends. The system working together is what makes a cow. That's synthesis. Now, on the other side, if you're trying to figure out why a particular cow is limping, you don't think about the head other than to keep it from damaging systems that are important to you. That's analysis. Unless you're thinking it might be a neurological defect, like, mad cow disease. But yeah.
Well, and that's a great example of that, right? Like if you were looking at the leg and there's something else going on, you have to have a synthesis-based understanding of the cow to actually troubleshoot that. Whereas if it's okay, there's a ligament screwed up in the leg, I can analyze and go, here's the issue, and not think of an external thing other than the problem I'm looking at.
Yeah. I mean, doctors do this when they're diagnosing you. That's why they ask sometimes really weird questions, is because they're doing it based on a rule out kind of attitude. So,
yeah. Now, while you're planning out a feature, you are pretty likely to use analysis to break that feature down into smaller, deliverable, discrete chunks of work, or your company's going bankrupt because the developers are going to have no direction, right? Like that, you're going to use analysis when you're building. You're going to break things down.
Yeah. Object-oriented programming, domain-driven design, and a lot of other things we've discussed are great for this, but can get in your way when you're trying to view the system holistically to deal with an emergent problem. A lot of developers have a hard time visualizing second and third order effects of decisions from one system when those manifest in another. This is really interesting. I was, again, while we're waiting on some stuff to load, having conversations with the junior developer on my team and talking to him about best practices and understanding the why behind them. Because when you understand the why behind them, you understand when they apply and when they don't. And that's this way with a lot of these. If you're a software developer, you've been there. It's 9 p.m. You're finally unwinding from your work. Your phone buzzes with an alert. Something's broken, and your mind already racing at what could be wrong. Is it global? Is it the server? Is it the network? Is it another app on the network that's causing this problem? Did I introduce a bug in my last deploy? Now, the whole team scrambling from tool to tool and messaging person after person to find and fix the issue. That won't happen if you get New Relic.
New Relic combines 16 different monitoring products that you'd normally buy separately, so engineering teams can see across their entire software stack in one place.
More importantly, you can pinpoint issues down to the line of code so you know exactly why the problem happened and can resolve it quickly.
That's why dev and ops teams at DoorDash, GitHub, Epic Games, and more than 14,000 other companies use New Relic to debug and improve their software.
Whether you run a cloud native startup or a Fortune 500 company, it takes just 5 minutes to set up New Relic in your environment.
That next 9 p.m. call is just waiting to happen. Get New Relic before it does, and you can get access to the whole New Relic platform and 100 gigabytes of data free forever. No credit card required. Sign up at newrelic.com/CDP. That's NEWRELIC.com/CDP. newrelic.com/CDP.
So, next, adjust causality to adjust effects, not the other way around.
Right. And this is kind of weird, right? While you might get a surge in traffic that overloads a database, and you might be able to alleviate that by simply throwing more resources at it, that does not work forever.
Essentially, you want to buy vitamins, not aspirin. Unless you're trying to prevent a heart attack, then you get the baby aspirin.
Right. Well, you're going to still potentially buy aspirin anyway, right?
Yeah. But you still end up needing some aspirin on occasion. I'm more of an ibuprofen person myself, maybe a little acetaminophen. Not really much of an aspirin thing. It permanently binds to. Sorry, way too much medical stuff. Anyway.
Yeah. Well, whiskey's just as good.
Whiskey works.
Yeah.
I drink a little bit of a tea made from the bark of a willow.
Well, back to it. When you have one of these situations, you may have to chase the ultimate cause through several systems. In fact, that's likely, especially as your system gets bigger and more complex. However, it can be really tempting when you find the problem and you're like, oh, here's the root problem. And it's, 2 apps away from me, in the graph of how all of our crap interacts. I want to fix it over here. That is probably not the place to do it in many cases. So what my approach in these kind of situations, now bear in mind, this is distributed scenarios, right? This isn't like, oh, here's a single app and these are components talking. These are things talking over a wire, potentially with queues and all kinds of other crap in the middle. I typically try and understand the ultimate cause, so I know where stuff is coming from, but I try to directly address the proximate cause. In this case, I would rate limit, put the thing behind a queue, do something so that a particular app can't overload this part of the system. Otherwise, you end up gopher whacking causes, right? Because you fix something in this one little subsystem way over here, and that changes the load pattern and it breaks something else somewhere else. And then somebody makes a change 6 months from now and hits your app and breaks it the same way the other dude did, because you didn't fix the cause close to where it manifested. And the real issue is that you're moving emergent behavior around the system. And so you're making unpredictable situations appear more unpredictably.
Yeah. So next, understand that system boundaries are abstract tools for thinking, but not particularly real. So you have to break down a system and analyze its constituent parts to be able to understand them. Like, you really have to understand each individual part to understand the whole. However, you need to understand that the separation of components within a system is a bit arbitrary.
Right. This is always fun for people that don't have a deep level of things like biology, right? When you're like, oh, what part of the gene does this? It's like, it's the gene and like all these other things too. It's the whole genetic code, right?
There are very few things that are like that are that specific.
Yeah. Most things are not discrete. They're continuous, and we draw a boundary somewhere because we have to, or we just go crazy. Yeah. Things going out of and coming into a system are going to impact that system. The behaviors of dependent systems and systems on which your code is dependent will change over time, and often when your system hasn't changed at all.
Yeah.
Right. Because, you got a static piece of code that, it works and it's out in production and you don't have to touch it. Well, somebody else is probably using that.
Yeah. No, in essence, your area of responsibility may end at the system's edge, but the area that is going to cause you problems is bigger than just your system or just your area of responsibility. Systems aren't separate if they're communicating. Even if they're doing it through abstraction, they're not completely separate.
Right. Like, this is why, like in security, high security environments are like air gap it, period. Because they know that if packets are going out to the internet, they're vulnerable at some level, right? They're now part of that worldwide system that they don't want to be a part of. And of course, there's still ways to get around that too. But that's kind of the understanding here. In general, you should be very accepting of data coming in so that you don't break your collars. So you go, okay, hey, here's some validation errors, here's some stuff, but you don't just like choke and throw an error or, block them from pushing anything else into the system or those kind of things. And you also want to be really strict as far as structure in the data that you send out. So you want to make sure that it's correct when it goes out, so that you don't break your dependencies. Essentially, it's it's like saying, okay, I'm going to tolerate insults without getting mad, and I'm going to try to be nice to other people, because I'm trying to avoid having a conflict. Right. Now, obviously, in real life, as a human being, there's a limit to how well that works. But in a programming environment, that's kind of what you want to do so that you're not the problem. Because if nothing else, if you just pass on the problem, down the line, either somebody else solves it or somebody else doesn't, and it's going to trend to making the less resilient parts of the system break instead of the more resilient parts, and then you can fix those because you're instrumenting things, right?
Yeah, that makes sense. And it's funny because I literally had a conversation about kind of systems thinking today. We were going over some code, and I was explaining why, like, making two calls to the database for the same kind of like, it was basically, well, two calls to the API. It was basically, all right, we're getting a little bit of user information from here and a little bit of user information from over here. And like there were two separate API endpoints because the code we inherited had one and then another one was added. And I was explaining to the junior developer I work with, I was like, all right, so, if we didn't have control of the API, yeah, making two calls to it would be fine. But we're writing the API. Why are we making two calls across the wire when we could make one?
Yeah. Well, and what happens, in a system like this, where one of the calls fails and the other one doesn't?
I know that was the other thing that I explained.
Or it gets out of sync.
Yeah.
Or like a deploy happens in the middle. Like, yeah.
Oh yeah.
It gets ugly quick. And once a junior developer, like watching that click over, you can see it in their eyes once they realize what could go wrong with something like that. But it's hard to explain it until you've seen it.
That's true. That is very true.
Now, the final one, this is something that kind of came from a friend of mine, and that is, well, no, it didn't kind of, it did. And it was a completely different context, but know the difference between landscape and landscaping. There are things that you can change and things that you can't. So this is why the whole landscape versus landscaping, right? You can fix the landscaping in front of your house. You can say, hey, I don't like this tree right here. I'm going to cut it down. You can't fix the landscape behind your house. I don't like that mountain. You're probably not going to move it realistically. It's understanding the difference between the stuff that is actually mutable by you and the stuff that isn't.
A typical cue for thinking something is changeable when it isn't is continual use of the word should. Oh my goodness. Oh, I hate that word.
Yeah, I do too.
And a typical cue for treating something mutable that isn't is the word can't.
Yeah. Those are like definite clues that you will hear in conversation. And when you start looking at that, you go, okay, like, and bear in mind, this isn't always true, right? Like this is a heuristic for going, I should pay attention right here, because it is true often enough when you hear these words that a testable assumption is the next thing coming, right? This should be X way. Well, what if it isn't X way? Or this can't be done? Well, what if it could be done?
Yeah.
Because it may not be possible for somebody else to do this right now, and you're assuming that they're never going to do it, but all of a sudden we get quantum computing 10 years from now and it is possible. What happens to the system? And start kind of having those kind of thought processes, not so that you could deal with quantum computers, because that's got to be a bigger issue than just this, but it's more of a thought process of how does this system break? Where are the limits?
Yeah. When you are given a testable assumption, test whether it's true and whether it can ever be false, which is interesting. Like, if you think about the scientific process, I mean, most of you guys probably remember this from, do we get it in high school, college-ish time frame? I don't know. But, you always start with what they call a null hypothesis, which is that your null hypothesis is the opposite of whatever you're trying to prove. If you're trying to prove that, the ground is hard, I'm just making stuff up at this point, then your null hypothesis would be the ground is soft.
Right. And then you throw your junior developer and see if they bounce.
Yeah. Something like that. But, don't throw junior developers at the ground to see if they bounce. That's not a good idea. We do not recommend that. This is not a recommended use of your junior developers.
Yeah. They're not so good for such hard problems.
Wow. So the idea here is that you're not trying to disprove anything. All you have to do is prove it right once. You don't have to prove it in every circumstance. It's like you prove that the ground is hard in one circumstance, then your null hypothesis is false. Because you're not trying to disprove. You're not trying to prove that the ground isn't soft or something like that.
Well, and this intersects with how you deal with complex systems too, right? Because the thing that gets you is not the normal course of events. The thing that gets you is the one-off that you're like, how in the world did that even happen? And you get nailed by it, because you didn't think through, the possibilities at some level, right? Something gets missed. And bear in mind, it may not be, like if you got, let's say Beej and I are in the room and we're talking about some program, right? And we're writing parts of it together. Well, neither of us may actually be at fault for this. The conversation between us is what's at fault, right? Because we together did not have enough to catch whatever that thing was. So it's definitely a real issue. So guys, early in your development career, you can often get by with treating your code as if it lives in isolation. Not only is this a necessary stage of your own growth, but at some point you do have to kind of consider the broader ecosystem in which your code lives. The way you have to think about this at scale is going to be different than what you had to do when you could focus on a single application component. However, it's hugely valuable to your career to be able to do this in both modes, to be able to swap between them. Now, in the Aftercast, we're going to discuss some ways that team leads and senior developers can help junior and mid-level developers become better at systems level thinking, because it's kind of a painful process. Anything we could do to make that easier is going to help our teams be more successful. That's pretty much all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at completedeveloperpodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/completedeveloperpodcast. You'll get extras, including a weekly Aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.completedevelopernetwork.com. Thanks for listening. See you next time.